Okay, we are going to solve by factoring. Look, this little beaver is going to solve a problem. He's going to make a little dam. So we are solving by factoring. First of all, there's a thing called the zero product property. What it says is if you multiply things together and it equals zero, at least one of the factors has to be zero. For example, if I multiply 4 times something and I get 0, you know that something has to be 0, right? So if I have this thing multiplied times that thing and my product is 0, that means either x plus 4 has to be 0 or x minus 5 has to equal 0. Now it can be an and. How do I solve that? We would subtract 4, so we would say x is negative 4. Over here we would say x equals 5. So my solutions are negative 4 and 5. Those are the two numbers that make this equal 0. If I put negative 4 back in there, negative 4 plus 4 times negative 4 minus 5. Negative 4 plus 4 is 0 times negative 9. That equals 0. If I put 5 back in there, 5 plus 4 times 5 minus 5, 9 times 0, that equals 0. So those are the values of x that equal 0, and that's what we're doing when we're solving. So what are the values of y that makes this equal 0? Well, it's already a multiplication problem. This times that, right? So we have y plus 1 could equal 0, which means y could equal negative 1. Or we have y minus 3 could equal 0, which means y is 3. So those are the two solutions to my problem. If y is negative 1, the whole thing is 0. If y is 3, the whole thing is 0. Now look at this one. Oh, look at him. He goes, I got this. Got two things being multiplied, 4 times this whole thing. So if I set 4 equal to 0, that's just silly. That doesn't tell me anything. There's no variable in 4. It's a constant, so I don't have to worry about that one. What I do have to worry about is 4r plus 3 equaling 0. So if I subtract 3, I get 4r equals negative 3. Divide by 4, r is negative 3/4. And if I wanted to check this, I would say 4 times negative 3/4 plus 3. Remember, we do our parentheses first, and inside the parentheses, I have to do this multiplication. That's negative 3 plus 3. Negative 3 plus 3 is 0, and 4 times 0 is 0. Viola, it works. All right. So now I actually have 3 factors. Most people only see 2. They see the 3 and the d, and they see the 10d minus 5. So I'm going to set each one of these equal to 0. Look at his little teeth. Ooh, he needs to use some whitener. Look how yellow those are. Divide both of these by 3. I get d equals 0. Add 5. I get 10d equals 5. Divide by 10. I get d equals 1/2. So these are my two solutions that make my problem equal 0 if I substitute them back in. All right, look, he looks like he's fishing. Put a little fishing pole in there, a little bobber. He's going to catch some fish. All right. 1 times 1 times 1. We got 4 factors here, but we're going to look at it as 3 different groups. 2z could be 0. Z minus 6 could be 0. Z plus 2 could be 0. On this one, if I divide by 2, I get z equals 0. There's one solution. Add 6, I get z equals 6. And subtract 2, I get z equals negative 2. Put 0 back here. 2 times 0 times 0 minus 6 times 0 plus 2. 2 times 0 is 0 times negative 6 times 2. 0 times negative 6 is 0 times 2 is 0. Put 6 in here. 2 times 6 times 6 minus 6 times 6 plus 2. 2 times 6 is 12 times 6 minus 6 is 0. 6 plus 2 is 8. 12 times 0. Look how this works. Put negative 2 in there. 2 times negative 2 times negative 2 minus 6 times negative 2 plus 2. 2 times negative 2 is negative 4. This is negative 8. This is 0. This is 32 times 0. See how each one gives us 0. All right, so we've got 1 times 1 times 1, 3 different factors. So I'm going to take k minus 4, 2k plus 1, and k plus 6. This is going to be our secret word right here, because this, when I first looked at it, did not look like a beaver. So we're going to say beavers resemble, let's lose that big word, resemble rats. Doesn't that look more like a rat to you than a beaver? I don't know. So k minus 4 could be 0, which is k is 4. 2k plus 1 could be 0. Subtract that 1. 2k equals negative 1. Divide by 2. K is negative 1/2. And k plus 6 could be 0, which means k is negative 6. At this point, I hope you just trust me that if I put them back in there, it makes them 0. Okay, I don't know how many. Okay, I'm tickled by this one because my eyes immediately went to this box down here, okay, because that's where the problem is. So what I saw was a hair piece. I thought this was someone's head, like his little eye is right here. So beavers are little tricksters, aren't they? They can resemble rats and full heads of hair. Wow. All right, this is your checkpoint. Solve by factoring. Right now, you're not actually factoring. They're already factored. You're just setting each factor to 0 and solving them. Oh, I hope the next one's more serious looking. Pause and do these. All right. Yep, here he comes. Now, honestly, he looks like a hippo in that picture. Beavers are just amazing creatures. They're little chameleons. So, and forget rats. Beavers are chameleons. All right. Shut up, Evans. Get to work. To solve a quadratic equation by factoring, step 1 is to have it in standard form. Ax squared plus bx plus c equals 0. Okay, so it has to equal 0. Step 2 is to factor. Okay, you're going to factor using greatest common factor, the big X, grouping, difference of squares. Okay, those are all of your little, that looks horrible. Look at how messy I am. I'm a chameleon too. You have to try to be able to read my writing. I disguise it as messy. You have to factor using all those factoring terms or methods that we have learned. And then you're going to set each factor equal to 0 and solve. So when we look at this problem, is it equal to 0? Check. Number 1 is done. So we are going to factor. This is a 3-term trinomial. 1 times negative 30 is negative 30. I'm looking for the factors of negative 30 that add up to negative 7. It's going to be negative 10 and 3. So f squared minus 10f plus 3f minus 30 equals 0. I'm going to go to grouping now, pull out an f minus 10. These have a positive 3 in common. Pull out the 3, f minus 10, it still equals 0. And I'm going to pull it all back together. F minus 10 is my common factor with f plus 3 as my leftovers. All right, that is all old stuff. The only difference is I put this little equals 0 at the end. So f minus 10 equals 0, add 10, f could be 10. That is my solution. F plus 3 could be 0, subtract 3, f would be negative 3. These are my solutions. They are the problems that make this true. If I put those in, that makes the left side equal the right side. Oh no, I just saw that this was one of those come in things. I bet I'm supposed to erase this and they're going to give you other answers. Let's see what happens. Yep, set the equation equal to 0, factor by whatever method you need, and set all factors equal to 0 and solve. There we go. Had I paid attention, I would have known that that was going to be there. So you're all set to go. All right, this one doesn't have any come in things. I'm ready to go. But first thing says get it equal to 0. It is not. So I'm going to add 2 to both sides. So I have 20w squared minus 14w plus 2 equals 0. Look at this is the teacher. Lecture, 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 lecture. Here's the student. Bored, 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 not listening. So sad. I'm going to pull a 2 out of here. Actually, I'm not going to tell you that. I'm just going to pull a 2 out. And I get 10w squared minus 7w plus 1 equals 0. You don't have to pull out the greatest common factor when you are solving. It just makes it easier. You're working with smaller numbers. So we're looking for -5 and -2. I'm going to leave that 2 right there. I'm going to go ahead and say 10w squared minus 5w minus 2w plus 1 equals 0. I'm going to do my grouping here. I'm going to leave the 2, and when I group, I'm going to pull out a 5w, and I get 2w minus 1. Pull out a -2, and I get 2w minus 1. This is getting squishy. So I have 2 times 2w minus 1 times 5w minus 2 equals 0. That's all the old stuff. Now, to solve it, remember, we can set 2 equal to 0, but that's a waste of our time because it doesn't have a variable. 2w minus 1 equals 0. Add the 1. Divide by 2. There's one very small solution. 5w minus 2 equals 0. Add the 2. Divide by 5. There's my other solution. Those are the two numbers that when I substitute them in for w, it makes the left side equal 0. All right, yep, okay, so the student has become much more curious. What you got, what you got, what you got? So when I look at these, the first thing I need to notice is they all have an x. When I take out the x, I have 18x squared plus 2x minus 5. Remember, for a trinomial, which is a big X thing, I really need this to be x squared. There's going to be times that we change it, but for right now, we're at the level where we just want it to be x squared. I can't do it with x cubed. I'm going to go over here and do my big X. 18 times -5 is -90, and I'm looking for 2. That would be good if I could see them. Is 18 times 5 90? I'm not even sure about that now that I did that for you. Yep, that's 90. So I'm going to have to write down all my factors of -90. It's going to be -190, that's not it. -2 and 45, that's not it. -3 and 30, that's not it. -5 and 18, that's not it. -6 and 15, that's not it. -7, -8, -9 and 10, that's not it. What did I do wrong? Okay, guys, what did I do wrong here? Let's pause this. All right, I'm going to be honest. I'm not sure we're quite ready to do this one. So for right now, we're going to skip this and we'll look at it later. I do not see what I did wrong. I think we have to use a quadratic formula, which we're not ready for. So we're just going to move on. Boom. All right. So this guy's going, no, we must solve this. We must solve this. We cannot move on. We must solve these. Well, we can do this one because this is two terms with a minus. So this is a difference of squares. So remember, that's a plus minus equals 0. What's the square root of 4x squared? 2x. What's the square root of 25? 5. So 2x plus 5 is 0. I'm going to actually do every step here for you because you guys have trouble when you have fractions. You tend to do a little freak out dance and you mess up. So show every step. So -5 halves, 2x minus 5 equals 0. We would add 5 this time. 2x would equal 5. Divide by 2. X would equal 5 halves. Okay? Difference of squares. Easy to factor, then just solve it. All right, this one, he's like, I'm just walking away. Look at him. He looks like he's very bored. But it doesn't equal 0. So I'm going to add 5x to both sides. So I have 10x squared plus 5x equals 0. Now, guys, this is just a me thing, and I think most of you are going to want to do the same thing. You always want to move it to where your x squared term is going to be positive. So I could have moved this all to the right instead of the left, but I want to keep my x squared term positive. It's just easier to factor with the positive leading coefficient. Greatest common factor, these both have a 5x. If I divide by 5x, I get 2x plus 1 equals 0. I am factored. So 5x could equal 0. Divide by 5. X is 0. 2x plus 1 could equal 0. Subtract the 1 and divide by 2. X is -1/2. half. All right, let's try the next slide. We're getting close to the end. Oh my goodness, look at him. He goes, no, 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 no. Again, I got a lot of moving. I can either move both of these to the right or all three of these to the left. A lot of you are going to say, let's go to the right because it's shorter. Nope, I'm not going to do that. I'm going to go to the left because this is my bigger h squared term and I want to stay positive. So I'm going to subtract 2h squared. I'm going to subtract h and then I'm going to add 4. So these all cancel. 4h minus 2h is 2h squared. Negative 7 minus 1 is, I'm sorry, that's a positive 7 minus 1 is positive 6h. And then there's a plus 4 equals 0. I'm going to take out my greatest common factor of 2. So I get h squared plus 3h plus 2 equals 0. I'm going to go 2 and 3 and I get 2, 1. Okay, I'm going to go ahead and do that factoring over here. It would be h squared plus 2h plus 1h plus 2. Go to grouping, pull out an h plus 2 plus 1 times h plus 2. So when I bring it back over here, it's h plus 2 times h plus 1 equals 0. Can I set 2 equal to 0? Yes, waste of time. H plus 2 equals 0, subtract 2. H is negative 2. H plus 1 equals 0, subtract 1. H is negative 1. Well, that was way more fun. All right, so this is checkpoint 2. You are going to factor all 4 of these. This one and this one, they don't equal 0. I'm going to tell you, take this to the left, take this to the left. When you take them to the left, make sure you put them in the correct form. So it's going to be ax squared, your x squared term first, your x term second, and your constant third. So this, oh, I was using white again. This will sneak behind the x squared. This is going to have to sneak in the middle. So be careful with that. Look at this. Tim